A science revolution in green chemistry, launched 20 years ago, is paving the way to a sustainable world that supports a healthy and vibrant economy. The science builds on great achievements by chemists and chemical engineers.
For 150 years or more, chemists have been finding out ways to put together new molecules. And they've done it in a way that have achieved astounding things.
Modern chemistry has improved our lives, provided an amazing array of consumer products, put food on our table, and saved lives with new medicines. Yet many of these achievements have come with a price.
Now, with all of those accomplishments, there's been one piece that's kind of been missing. And that piece is ensuring that while we achieve those goals, we also don't cause harm to human health and the environment. That's what green chemistry is all about.
Green chemistry is the design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. EPA is at the forefront of this green chemistry movement. In partnership with industry, innovations are moving from the lab to the marketplace.
Green chemistry is something that EPA is advancing both by engaging with the outside world, giving grants, engaging on education, industrial partnerships, but also in research that goes on right in EPA labs.
One of the things that we do best at EPA is finding innovative solutions to real-world problems. That's what green chemistry is about. The research that we do has to be focused on the needs of the country.
Few needs are more pressing than the challenge to meet our transportation energy demands. Biofuels promise to play a larger role, although obstacles remain. Promising new technology developed by EPA engineers, called membrane-assisted vapor stripping, can more efficiently separate water from the alcohol and cuts the energy demand in half for making the biofuel. Less energy consumption means less air pollution and also reduced manufacturing costs. Innovations are also leading to new ways to make nanomaterials. EPA scientists are working to ensure that these tiny wonder materials, being produced for so many different products and applications, do not cause harm to the public or the environment.
We don't use any toxic material at all to make these nanomaterials in the first place. That is the key thing in our approach. We use sugar, we use antioxidant present in tea, coffee, wine or wine waste, like grape pomace.
Dr. Raj Varma and his team have developed dozens of new and patented methods for the chemical industry and others to make compounds in environmentally friendly ways using nanomaterials as catalysts. The consumer products you use, clothes, cosmetics, cars, and electronics, to name just a few, are made for the most part using a similar chemical process. Various chemicals are mixed together in large amounts of potentially toxic liquids, solvents, to get a final chemical product. Pharmaceuticals are made in this fashion as well. 80 to 85% of the waste that is generated in pharmaceutical processes is solvent-related.
So if we can remove the solvent from a synthesis paradigm, we can remove a significant amount of waste.
EPA developed the spinning tube-in-tube technology that takes solvents and their waste out of the chemical-making process. At the pilot stage, the spinning tube-in-tube reactor that's being used in Dr. Michael Gonzalez's lab fits on a large table and can produce 2 to 12 tons of chemicals a year, the same as a large chemical reactor using solvents. The technology reduces waste, produces chemicals much more quickly, and reduces production costs. To design greener chemicals, EPA scientists have developed computer software which is used by molecular designers around the world. The tool is called TEST.
So what this allows you to do is, before you even walk into the laboratory, you can draw the structure of the molecule that you're thinking about making. Based on that structure, this software program will give you some estimation as to the toxicity of that compound.
The advantage of being able to predict toxicity by a computer and not having to go to a laboratory, obviously saves time, saves money. A lot of these studies that are done in the lab take years. We can do an evaluation in seconds on a computer.
Green chemistry is being adopted and embraced by business and industry. But for every product or industrial process that's been reinvented in this sustainable and green way, there are probably 100 that have yet to be looked at through the green chemistry lens.
Green chemistry has shown us what's possible. It's a framework for saying that we can design our products and processes so that they're sustainable, using renewable materials, using manufacturing processes that generate less waste and use less toxic substances, having products that aren't of concern for our children or ourselves or our ecosystems. And at the end of life, these substances are going to go back into the environment and degrade in innocuous ways. It's shown us what's possible. Now the question is, will we engage on this challenge, this great scientific challenge, with the urgency, with the focus that is going to be needed? Quite frankly, with the focus that sustainability demands. We can, and I believe we will, because we must.